In short, there's no proof for the current theory of how planes fly. No empirical evidence and no experiment on real aircraft, nothing. This means that the FAA and Boeing don't know how planes remain airborne. Worse, their theory is impossible and implausible. Clearly planes fly, but they just don't know how. In short, almost everything that floats displaces a mass of air or water that is equal to their own mass. If they don't, then they sink due to gravity. Boats displace water to float. Planes displace air down to stay airborne. Obviously, planes fly in the colloquial sense. First, let's be clear what gravity is. Gravity is a force that acts to push or pull heavier, higher mass and denser objects towards the ground. In short, planes fly because the propellers push the plane forwards, pushing air over the wings. The wings then convert this horizontal airflow into vertical lift. The debate is over exactly how lift actually occurs. I present two opposing views as to how planes fly. One view, taught at flying schools, is based on magic. The other view is based on a rational observation of reality. Every pilot is taught that planes fly because of the upper airflow increases in velocity when it flows on the curved part of the top side of the wing, creating low pressure. This process relies on something called Bernoulli's principles. This low pressure then generates vertical lift. We call this the conventional theory. There's only one problem. It's total bollocks. It's obviously utter nonsense because it doesn't correspond to what we see in reality. Specifically, it cannot explain inverted flying where the wing curvature faces downwards, how aerobatic planes can fly with symmetrical wings and thus symmetrical curvature, how some planes can fly with only straight wings and no wing curvature, and how speedboats can generate lift without wings. Also, the logic of conventional theory is false. Correlation is not causation for low air pressure and lift. There is no upward airflow on the wing to support vertical lift. Bernoulli's principle doesn't apply to aircraft wings because they're not enclosed systems, and this theory can only describe a stall, it can't explain it. For now, let's just focus on the first of these many problems. The conventional theory cannot explain how planes can fly inverted, as the curvature of the wing is now facing downwards, not up, so the wing should not be able to generate lift and the plane should fall towards the ground. Obviously this doesn't happen as planes fly inverted in the real world, so conventional theory fails. Aerobatic planes typically have symmetrical wings with equal curvature on both sides of the wings. This would produce equal lift both up and down according to the conventional theory. Some planes fly just fine with flat wings. Wing curvature is not essential for flight. Critically, lift only requires a wing with a positive angle of attack. That is, a positive vertical angle between the wing and the direction of flight. Boats can rise out of the water and float on the air for the same reason as planes. As the boat goes faster, it displaces a greater mass of water and air, pushing the boat upwards. The conventional theory is full of logical fallacies. Bernoulli's principles of fluid dynamics don't apply to planes, as the conditions for these principles don't exist on wings. It is not part of an enclosed system. The airflows are separate and not part of one stream of fluid. There is no equal transit of upper and lower airflows. Aviation can't claim to use Bernoulli's principles, as it doesn't actually use any of Bernoulli's mathematical formula or equations in the calculation of lift. But more on Bernoulli's principles later. Plenty of experienced and reputable people in aviation dispute the conventional theory of flight. Most flying instructors will tell you that the official explanation for how planes fly is incomplete at best. Even NASA claims that the conventional theory is incorrect. Go and take a look at their website. The standard diagrams used by the conventional theory actually demonstrates mass displacement. Take another look at this diagram, which every pilot has been taught. It clearly demonstrates the mass displacement theory, with the air mass being displaced downwards. It's literally in your face. According to the conventional theory, the curved part of the wing is where the lift is generated. But this part is facing at angle to the vertical, not directly upwards. So following the logic of this theory, the lift should be generated in this oblique angle, not directly upwards. The two-dimensional diagrams of airflows and wind tunnel experiments used by the conventional theory are so oversimplified that they're grossly unrealistic and inaccurate. The conventional theory uses diagrams such as these that depict wings that can't fly in the real world. Unrealistic diagrams, unrealistic theory. Garbage in, garbage out. Although these are unrealistic, two-dimensional experiments, they demonstrate the logical fallacies of the conventional theory. Strangely, wind tunnel experiments are never used to measure lift and prove the conventional theory to be correct. A standard experiment involves a machine blowing parallel streams of smoke horizontally across a wing. Note how attention is limited only to the airflows that are close to the wing. The difference in air speeds between the upper and lower airflows are not very significant, so this cannot be a major cause of lift. This shows that the airflow splits in two at the leading edge of the wing and doesn't rejoin later. The air is not one stream of air, so Bernoulli's principles do not apply. The upper airflow doesn't increase velocity in absolute terms, so it cannot produce lower air pressure relative to this air mass above it, hence it cannot generate lift. Just to reiterate that two-dimensional wind tunnel experiments are so oversimplified that they are actually wrong. Airflow is three-dimensional. These theories and principles of lift can be easily tested. Next time you're in a car, just stick your hand out of the window and see what causes lift. Now we revisit the problems with Bernoulli in more detail. Bernoulli's principles are really aimed at describing fluid dynamics in enclosed systems, things like water pipes. Bernoulli cannot be applied to fluids like air and their interactions with wings, as it is not an enclosed system. There are also two more conceptual problems with applying Bernoulli ideas to wings. Namely, these principles are most appropriate for moving fluids, not static air. The often quoted Bernoulli paper experiment is inappropriate as it involves paper, not a metal wing of a plane. Bernoulli's logic doesn't translate to planes in flight. Bernoulli lived in the 18th century. Who knows what he would have thought of people applying his ideas to planes? Aviation can't claim to use Bernoulli's principles, as it doesn't actually use the Bernoulli's mathematical formula and equations. One problem is that the paper never rises higher than the point of the blowing air. So there's no way for a low air pressure wind to generate vertical lift on a wing. The critical factors that influence vertical lift on a wing do not include low air pressure on the top of the wing. Mass displacement theory is based on the same principles that explain why hot air balloons and boats float, namely that they displace a mass of air or water that is equal to their own mass. If they don't, then they sink. It is generally agreed that planes' wings displace some air downwards that help them stay airborne. The debate here is on how much lift is generated by mass displacement. In normal flight, the wings generate lift in two ways. Firstly, the underside of the wing pushes air down, as reflected by the high air pressure under the wings. And secondly, the curved upper side of the wing also pulls air downwards, also generating lift. This is reflected by the low air pressure on the top of the wings. Propellers and wings have the same basic design and functions. Propellers push air onto the wing. The wing then converts this into vertical lift by pushing the air down. Or put it another way, the moving propeller is pushing stationary air backwards. The stationary wing then pushes the moving air downwards. In inverted flight, the wings still function in a similar way to normal flight. The nose of the plane is raised so that the wings maintain a positive angle of attack. The wings continue to displace air downwards, but are less efficient as the wing curvature is also inverted. As the propellers are angled slightly down, this boosts lift by pushing more air downwards. Newton's third law states that for every action there is an equal and opposite reaction. Mass displacement theory is consistent with Newton's third law. The underside of the wing pushes down on the air, and thus the reaction from the air pushes the plane up. On the other hand, the conventional theory makes little mention of Newton's third law apart from discrediting it as the cause of lift, but that's all. Also, the conventional theory makes no reference to the energy process involved in generating lift. In reality, the energy from the engine is used to push the air mass down and the plane up. Now we take a look at the physics of flight at the molecular level. At rest on the ground, the forces on the plane are in balance. This demonstrates how lift is a result of the interaction between the air molecules and the wing. The dots in this animation represent air molecules. In flight, more air molecules hit the underside of the wing, and each molecule strikes the wing with a greater force compared to the top side of the wing. This generates lift. The top side of the wing is angled away from the direction of flight, so it hits less molecules and hits each molecule with less force. So in flight, the plane is coming into more direct contact more aggressively with a greater mass of air underneath the wing than above it. This generates lift. Consequently, the molecular explanation of how planes fly is consistent with the mass displacement theory, but not the conventional theory. Speedboats can rise out of the water and float on the air. As the boat goes faster, it displaces a greater mass of water and air, pushing the boat upwards. It's clear that birds stay airborne by pushing enough air downwards to counterbalance their own mass. Wing vortices and backwash. Physical evidence for mass displacement is the backwash behind the plane. More evidence of aircraft backwash can be seen in these big Russian bombers flying over the tops of the clouds. The conventional theory makes little mention of wing vortices of backwash, except to say that they are a factor affecting drag. Vortices are a critical part of how a plane generates lift. This video demonstrates the wing vortices pushing the air mass down and backwards. Or to put it another way, these vortices is air going down. The equal and opposite force is pushing the plane up. some more proof of mass displacement theory with real examples of real planes. According to the mass displacement theory, to stay airborne, a 2,500 kg Spitfire needs to displace 2,500 kg of air every second. In this example, a Spitfire flying at 400 km an hour needs to displace 19 cubic meters of air every meter flown. These estimates are based on a few simple assumptions. In this example, a Spitfire flying at 400 km an hour needs to displace 19 cubic meters of air every meter flown. According to the mass displacement theory, to stay airborne, a 10,000 kg Harrier needs to displace 10,000 kg of air every second. These estimates are based on a few simple assumptions. These two examples are compared. The Harrier is about twice as efficient at displacing air compared to the Spitfire. These two examples provide proof of concept for mass displacement. Conventional theory provides no explanation of these dynamics. These two examples are compared. The Harrier has 4 times the mass compared to the Spitfire, yet the Harrier stays airborne while flying only twice as fast as the Spitfire. The Harrier is about twice as efficient at displacing air. There is a non-linear relationship between speed and lift. As planes fly faster, the physics of flight change and lift increases disproportionately with speed. Stronger wing vortices and greater air viscosity make it increasingly easier for a plane to displace more air every second and every meter flown. The faster the aircraft, the less wing curvature matters. Now, some practical tests of stalls to prove mass displacement. Take 2 identical planes, except one has a greater mass. As the speed of the planes declines, a constant altitude is maintained by raising the nose of the plane. The plane with the greater mass will always stall first. The plane sinks like a stone due to gravity. Mass is the only difference between the 2 planes in this example, and thus the only explanation for the stall. Take a plane in stable, cruise flight under normal conditions. Add an additional person to the plane. If nothing else has changed, the additional mass would make the plane lose altitude. The plane starts sinking. To compensate for this additional mass, the plane needs to generate additional lift by displacing a greater mass of air. This is done by raising the nose of the plane or increasing the speed of the plane. Here we do some practical tests to see whether each theory can adequately explain standard aircraft maneuvers. In normal, stable flight, all forces are in balance. Mass displacement can explain the dynamics of a climb, whereas conventional theory's logic fails as it predicts the reverse of what we see in reality. In a stall, mass displacement explains the plane is no longer displacing sufficient air mass to remain afloat, so sinks. The conventional theory has no theoretical explanation for a stall. Mass displacement can explain the dynamics of a descent, whereas conventional theory fails again, as it predicts that a higher speed means more low air pressure on the wing, and thus more lift. In a vertical descent, mass displacement theory is consistent with reality, whereas conventional theory wrongly predicts that the high speed and high pressure differential on the wing would generate lift. The logic of both theories is consistent with the dynamics of a plane banking in flight. However, only mass displacement can explain the dynamics of how the ailerons perform in a bank. The conventional theory fails to explain how the ailerons can affect the low pressure at the front of the wing to induce the plane to turn. Mass displacement easily explains the dynamics of how flaps affect flight, but the conventional theory fails to explain how flaps can change flight dynamics as seen. Ground effect feels like the plane floats down the runway. This demonstrates the mass displacement theory, even to the skeptics. Conventional theory has no explanation of how ground effect can impact lift within its theoretical framework. The influence of wind on aircraft is consistent with mass displacement. On the other hand, conventional theory doesn't explain how wind impacts flight within its theoretical framework. The results of these practical tests conclusively show that mass displacement theory is consistent with all the maneuvers made in flight, whereas the conventional theory is inconsistent with or fails to explain almost all of these flight maneuvers. At flying school, they only teach the conventional theory of how planes fly for a plane in a stable cruise flight. They never explain how it works in the different stages of flight or different flight maneuvers.
So what? Well, if you're flying, then your pilot doesn't know the true reasons how and why the plane stays airborne or stays afloat. No wonder so many planes still crash. Thanks for listening, and safe flying.